to America Reads Fun Learning Activities. We are college students who create learning activities for kids. Our activities are focused on reading, writing, and math. Thank you for joining with us to learn today. Hi everyone, my name is Lexi Herman. We are going to discuss how a slope of a line remains constant using triangles. We are going to be creating some graphs together and then using the triangles to help determine if the slope remains constant throughout the graph. I also have our slope sloth that is going to help us determine if the slope remains constant throughout the line or not. If you wish to follow along, you are going to need a writing utensil, a ruler, and 2 pieces of paper. Let's get started with today's video. Start learning about how to use the similar triangles to explain why the slope is the same between any 2 distinct points on a non-vertical line in the coordinate plane. First, in order to determine all of this, we need to make a graph. I'm going to take my first piece of paper and draw a 4-quadrant graph with 6 x coordinates and 6 y coordinates using my ruler. Please take a minute to pause the video and make this graph for yourselves. Now that you have drawn your graph, use your ruler again to draw any line from the origin 0, 0, going into the first quadrant. Now, take your writing utensil and mark any 2 points on the line. I'm going to mark my 2 points on the coordinates 1 and 1, and the other coordinate 2 and 2. After marking this line, we need to find the slope, or its steepness and slant, of the line. This is where our slope sloth is going to help us out. Let's use our equation for finding slope, which is y equals mx. Just a reminder that the m in this equation is equal to the change in y value over the change in x value, whereas the x in this equation is just equal to the change in x value. First, let's find the change in y value. To do this, we need to take our y2 coordinate and subtract it from our y1 coordinate. In my case, it would be 2 minus 1, which equals 1. Next, we have to find the change in x value. Like before, you will now take the x2 coordinate minus the x1 coordinate. For me, it would be 2 minus 1, which equals 1. We now have an answer of 1 over 1, which simply simplifies to 1. We can see that our sloth is hanging at a slope of 1. Now it is time to branch the 2 concepts together, an equation of a line and the formation of a triangle. In order to draw our triangles, we need to connect the points. For our first triangle A, connect our previously established points. For me, I am going to draw a triangle A from the coordinates 1, 1 to the coordinates 2, 2. Here, we know our slope is 1 because we already solved this equation. But what if we were to draw another triangle? Will it still have the same slope? Let's find out. On your line in your graph, draw another point. I'm going to draw another point at the coordinates 4 and 4. Clearly, triangle B is a lot bigger than triangle A. Do they still have the same slope if they are different sizes? From here, our sloth can help us determine if the slope from this equation is true or not. We can take the change in y minus the change in x to find the slope of triangle B. Let's do this together. First, take the y2 coordinate and minus the y1 coordinate. I will be taking my y2, which is 4, and subtracting it by the y1 coordinate, which is 2. This ends up equaling 2. Next, I am going to take my x2 coordinate and minus it from the x1 coordinate. Again, this is 4 minus 2, which ends up equaling 2. This then simplifies down to 1. Isn't the slope of triangle B equal to 1 the same as the slope of triangle A equal to 1? Thanks to our slope sloth, we can see that even though triangle B is bigger than triangle A, they still have the same slope on the line. Let's go through just one more example. Use your ruler to draw another graph. except this time have 10 y-axis and 10 x-axis coordinates. Once you are done constructing your graph, draw another line, except this time we are going to draw a line that goes through the y-axis. Please pause the video again to draw your graph and line. When you are done with your graph, take your writing utensil and mark your y-intercept, which is where the line crosses through the y-axis. In my scenario, the line passes through the coordinate 0, 2. After marking this line, we need to find the slope. Now that we have a y-intercept, this is added to our slope equation. The equation becomes y equals mx plus b, where the mx is still the same slope, change in y over change in x, and the b is the value of the y-intercept. On my graph, my y-intercept is 2 because the line hits the y-axis at the 2 value. Therefore, we found our b. That wasn't so bad, but in order to find slope, you have to mark another point on the line. Take your writing utensil and mark one more point on the line. This time, I am going to mark my point at 1 and 4. Now let's find the change in y value for our slope. We can use our 2 points, 0, 2, and 1 and 4 to do this. Take the y2 value, which is 4, and subtract it from the y1 value, which is 2. This ends up equaling 2. Next, take the x2 value and subtract it from the x1 value. In my case, it is 1 minus 0, which turns into 1. 2 over 1 simplifies down to 2. But now, how do we know if the line continues the same slope throughout now that it has crossed through the y-axis? Again, let's use some geometry to draw triangles and prove that statement. In order to draw our triangles, we need one more point to connect everything together. For our first triangle, connect the y-intercept and the previously established coordinate. In my case, I am going to connect my y-intercept of 2 to form triangle A to the coordinate of 1 and 4. Here, we note the slope is 2 because we already solved this equation using our new formula y equals mx plus b. Slope the sloth is here hanging out on a slope of 2. But now we have to draw another triangle to prove this equation. On your line on your graph, draw another point. I am going to draw another point at the coordinate 3 and 8. Now connect another triangle from the previous coordinate to your new coordinate. In my case, I will draw a triangle B from the coordinate 1, 4 to my new coordinate 3, 8. Like the previous example, triangle B is a lot bigger than triangle A. Do they still have the same slope if they are different sizes? Again, our slope sloth is here for the rescue. Again, we can take the change in y divided by the change in x to find the slope of triangle B. Let's do this together. First, take the y2 coordinate minus the y1 coordinate. I will be taking my y2, which is 8, and subtracting it from my y1, which is 4. This ends up equaling 4. Then, I'm going to take my x2 coordinate minus my x1 coordinate. For me, it is going to be 3 minus 1, which ends up equaling 2. This 4 over 2 can be reduced to 2. Now, both of our triangles have the same slope, even though they are different sizes. A big thanks to Slope Sloth for helping us out in our lesson today.
Thank you for learning with us today. We hope you come back and learn more. Please like and subscribe to our channel, and we will be back with more videos.